Hey Calc, section 3.3, I'm going to split up into 2 days, so first half today and then the second half tomorrow. I think I like section 3.3 better than section 3.2 because solving limits analytically is more of the arithmetic and the algebra stuff than actually having to look at and graph things like we did in section 3.2. So you probably will like this better as well because you're actually finding a solution rather than just looking at a graph, okay? These first couple problems, though, the first couple examples, I am going to kind of relate them back to the graph so that you can kind of see how and why this stuff works. But the first thing that I want to always say to you is when you're evaluating a limit, so when they ask for the limit, like this problem does right here, the limit as x goes to 2. Sometimes you will see the x minus 2 off to the side over there. Most of the time you will see the x goes to 2 on the bottom of the limit. This is how that it will be written most times. But if that's off to the side, it doesn't really, that's just kind of a notation thing. It's not really that big of a deal. But you always want to use direct substitution. So try plugging the number in to the equation that you're trying to find the limit of. A lot of times there's no problem plugging that thing in. Only if you have like a hole or a vertical asymptote there is when you have to worry about like dividing by 0 or things like that. But if you can directly substitute it in, do it. Always try to plug it in first. That's the first thing that I will always tell you evaluating limits. Try to plug the number in first, okay? So direct substitution, that is huge. Always try to plug it in first. Okay, some basic limit property stuff. Okay, let's look at example 1 right here. The limit as x goes to 2 of 3. This is what we're trying to evaluate, and they tell us that the answer is 3. Okay, they're giving us the answer to each one of these, by the way. But I'm going to show you why this is. So the limit as x goes to 2 of 3. This is like looking at the graph of y equals 3. Okay, y equals 3 on a graph is 1, 2, 3. This line right here, okay? No holes, no yucky stuff, no nothing. And they want to know as x goes to 2. So 2 on the x-axis, this dot right here. As we're coming in on the left side, or on the right side and on the left side, what is the y-coordinate approaching? Well, the whole line is at 3, so it's approaching a y-coordinate of 3, and that's why 3 is the answer, okay? So whenever you have just a single number here and you're evaluating a limit at any spot, it's going to be just that value, okay? This one here says the limit as x goes to negative 4 of x. That's what we're trying to solve for. So think about the line y equals x, okay? Y equals x is this guy right here that goes at an angle, okay, up 1 over 1, all the way across, and we're trying to solve for as he approaches negative 4. Negative 1, 2, 3, 4. Okay, where is he living at on the graph? 1, 2, 3, 4. Well, since he's up 1 over 1 or down 1 to the left 1, he's going to be at negative 4. Coming in from the left side, coming in from the right side, he's approaching a y-coordinate of negative 4. That point is negative 4 on the x, negative 4 on the y, so that solution is negative 4, okay? Same thing, I could just take negative 4 and plug it in for x, and I would get negative 4. That's just how it works, okay? Here, the limit as x goes to 2 of x squared. X squared is a parabola, looks like this guy. So I want to know as x approaches 2, okay, coming in from the right side, coming in from the left side, what is that coordinate? 2 comma what? If I plug 2 in, it's 2 squared, which is 4, okay? There's no hole or any bad places on each one of these, so we can just plug those limits in. Now, typically, limits, the purpose of a limit is to evaluate something where you cannot evaluate them at. So it's really kind of pointless to look at example 1, example 2, example 3, because, why would we want to try to find a limit if there's not a problem there? Limits exist to find values of things that we cannot already find the values for. But the reason why they're having us do problems 1, 2, and 3 is to get us kind of used to how to do this process so that we can apply it to things that don't already exist, okay? So usually we try to evaluate limits at places that are not, that have problems, that have like holes and vertical asymptotes and things, but they're just kind of warming us up to that idea by just looking at the graphs of things that already do exist, okay? So find the limit of these guys. First, always try to plug it in. So x, as x goes to 2, I'm going to try to plug 2 in here. 4 times 2 squared plus 3. I'm not going to end up with any problems there because there's no division by 0 or no negative inside of square root or anything like that. 2 squared is 4. 4 times 4 is 16. 16 plus 3 is 19. The limit is 19. So this is basically saying if the x coordinate is 2, the y coordinate is 19. That's where he touches on the graph. Okay? This guy right here. Now, if we look at this function, we do see that there is going to be a problem because I do have division, right? X plus 1 is what's in the bottom. So the number that I'm not going to be allowed to plug in would be -1. That's like my domain. My domain is everything that I can plug in every single number that I want to except -1. I'm going to have a problem when I plug -1 in. But look at where we're trying to find the limit at. The limit we're trying to find is at +1. There's no problems that occur at +1. So let's try to plug it in. 1 squared plus 1 plus 2 all over 1 plus 1. I'm plugging him in for x. 1 squared is 1. 1 plus 1 plus 2, that's going to give me 4 on the top and 2 on the bottom, so the limit is 2. So at an x-coordinate of 1, it touches a y-coordinate of 2 on the graph. Yes, I do have a vertical asymptote at -1, but they're asking for the limit at +1. It would have been more interesting to find the limit at -1 because that's why limits exist, but they're just asking for +1, so there's no problems here. All right, same thing here with x equals 0. I'm going to plug 0 in here and see if we end up with any problems. 0 squared plus 4 is going to be just the square root of 4, which is 2. Okay, so the limit is 2, and we're done. Okay, now, plus and minus 2, do we have to worry about plus and minus 2? Think about that process. The square root already existed, so we do not have to do plus and minus 2. It's just 2, okay? 3, let's try to plug 3 in. So 2 times 3 squared minus 10, and this is a cubic root, okay? 3 squared is 9. 9 times 2 is 18. 18 minus 10 is 8, so we're doing the cubic root of 8. Cubic root means what do I take times itself 3 times to get 8, and that is 2, so that limit is 2 also. So at an x-coordinate of 3, the y-coordinate is 2. No problems, no holes, no vertical asymptotes. None of these had any problems. Always try to plug it in first. Okay? All right, strategy for finding limits. So we're going to start to get ones in the rest of this lesson that you cannot find the limit of by just plugging it in, okay? So what do we do when we cannot plug limits in, okay? So like this one, the next example, find the limit, and we're trying to find it at x equals 1. If I try to plug 1 in, 1 cubed minus 1 over 1 minus 1, we will end up with 1 cubed is just 1, 1 minus 1 is 0, and 1 minus 1 on the bottom is 0. And this 0 on the bottom we can't have, so we can't just plug in. We have to do another strategy, okay? So what this box up here says is that if you are not allowed to plug the number into the function to find the limit, what you're going to try to do is take that f of x, which is this function here, and we're going to try to change him somehow, some way into a g of x that's equivalent to him so that I am allowed to plug this in, okay? So if this is my f of x, this x cubed minus 1, I want to try to change him in somehow, some way to make him a new function that's the same, that's equivalent to the old one, so that I am allowed to plug that in. Well, this right here, this f of x, when it's listed as a fraction like this, all this guy means is division, right? We're taking the top one and we're dividing by the bottom one. So if I want to simplify it, one thing I could do is just do some long division here and see if, he makes a new equation. So I'm going to take x cubed minus 1 and divide by x minus 1 on the outside. But keep in mind that you do have to put plus 0x squared plus 0x minus 1. You do need to have those placeholders in there. Otherwise, you'll end up with some bad stuff, okay? So first question we ask, how many times what do you have to type times x to get x cubed? And that's x squared. X squared times x is x cubed if I multiply them back through. X squared times -1 is -1x squared. And then we flip the signs. So minus plus, x cubes cancel out. 0x squared plus 1x squared is 1x squared, and I drop my 0x down. Okay, I'm kind of going through this a little fast. What do you take times x to get 1x squared? That's just 1x. X times x is x squared. X times negative 1 is negative 1x. And then I flip the sign. Crosses off. I have positive 1x. Drop the negative 1 down. And then the last time, what do I have to take times x to get x? And that is just a 1. 1 times x is x. 1 times negative 1 is negative 1, but then I have to flip the sign. So minus plus, and I end up with a remainder of 0. So this is what I'm talking about when I said, if this is f of x, I want to change him somehow, some way into something that is equivalent to him. So I did my long division, and we know that this guy is equivalent to what my f of x was to start with. So instead of finding the limit of this guy, instead of calculating this thing out right here, what we're going to do is we're going to do the limit as x goes to 1, but we're going to do it of x squared plus x plus 1 instead, okay? We're changing this thing right here, and we're changing him into what we get when we do the long division. And now I am able to plug that number in. So 1 squared plus 1 plus 1, that's just going to give me 3. So what I can conclude from that is, if I were allowed to plug 1 into this equation up here, and I didn't end up with 0 in the bottom, the y-coordinate that it would approach, the y value of the coordinate 1 would be 3, okay? There's a hole there, or a vertical asymptote there, or really there's a hole there if it's approaching a y-coordinate of 3. If it were a vertical asymptote, it would be approaching infinity or negative infinity. But since if I were to plug 1 in, or I were allowed to plug 1 in, 3 would be the coordinate where the hole would be located. Okay, so I think I'm going to go ahead and stop there. We'll save the rest of this for tomorrow. We'll talk about those things. You should be able to get part of the homework assignment done. It's written up on the board. Or, let me find it here. Homework for, I think I posted it on Google Classroom as well. 3-3, page 234, 8 through 44 by 4s. And 68. Those are the homework problems for this section. You should be able to get a start on those. We'll finish the notes for this stuff tomorrow. It is Friday schedule, so we do have shortened periods, but these two problems should not take us very long for that, okay?